Hi, hello, good evening, friends. Welcome back to our YouTube channel Mutim Official. As usual, today we will discuss about few topics or brief concepts of transformer. That's what I told in the last session. That we will continue transformer concepts in the next session. So, in line to that, I'll start today's session with a basic definition of the transformer. So, as all of you might be knowing about it, but still, a transformer is a static device which transforms the energy from one electrical circuit to another electrical circuit without having any physical contact between them. That means two electrical circuits are coupled together or connected together without any physical contact. That means they are coupled magnetically. In that sense, if one of the electrical circuit may be primary or secondary, if one of the electrical circuit is fed with some electrical energy, preferably it is AC, because transformer doesn't work on DC. In fact, it will be damaged. So the AC electrical energy is fed to the one of the electrical circuit, and this electrical energy will be transformed or transferred to the other electrical energy without any physical contact, and making this magnetic coupling, whatever you're calling it as a medium. So this is the basic function and definition of a transformer, and the efficiency of the transformer is more than 98%, since it is not a rotating device, and the rotational losses are also zero almost. It is having only iron losses as well as copper losses. So since the loss component or losses are minimum compared to rotational devices like generator or motor, the efficiency in the transformer is obviously very high, and the one and only machine or one and only circuit or device which can provide highest efficiency is transformer. So the transformer is a static device which transforms the electrical power or electrical energy from one circuit to another circuit without any physical contact or through the magnetic coupling, and the basic principle behind which it is working is Faraday's laws of electromagnetic induction. Okay. Now the basic interesting point here to know is what are the components or quantities that are maintained as constant in the transformer. Now, as I told you just now, a transformer is modeled with two different electrical circuits. So one of the electrical circuit might be termed as or is termed as primary winding or primary circuit. The other circuit, other electrical circuit is termed as a secondary circuit or secondary winding. Now, if the transformer is to be designed or if the transformer is to be constructed, these two electrical circuits are to be connected somehow, but not physically. So therefore, a magnetic medium, call it as a core, iron core, is placed between primary circuit as well as secondary circuit, and this magnetic core will be acting like a medium to have a induction process. So as I told you just now, the transformer is working on the induction principle but not the conduction principle. Okay. Now, what are the quantities that are maintained as constant? It is very interesting to know. As usual, I'll be writing today's date. Today's date is 15th May 2024. And it is about the transformer. Okay. Now let us take a small circuit. So whatever I am drawing here, it is nothing but the magnetic core. Right. can have some laminations here. If you want, you can show in that fashion. Okay. Now, so I'm going to connect a primary circuit or a primary winding. So this is nothing but the primary winding. Okay. Now I'm connecting a power supply, AC power supply. As I told you, sorry, I didn't mention. Transformer doesn't work on DC power supply. Instead, it will damage. Oh, sorry, it is actually load. So we should connect it at load. But what I will do, I will keep a switch here. I'll tell you why it is so. So let us mark it as switch. Now this I am connecting it to load. Okay. So the load may be of different types. It may be resistive, or it may be inductive, or it may be capacitive. Now let us take this voltage, input voltage is V1. Now think that case 1, the case 1 is on no load. So case 1 is on no load. That means here the switch is open condition. That means S is in open condition, right? Now the current, since let us mark it as not S, it is actually S2. Let us make it as S2. This also I am taking one switch here, so it is S1. Okay. In case 1, S2 is in open condition. Okay. Maybe this is at t is equal to 0. Now, not only S actually, both S1 and S2 are in open condition. S1 and S2 both are in open condition. So it's a normally an ideal condition, because power supply is not connected and load is also not connected. So it is simply a magnetic core wounded with two different windings. One is primary winding and the other one is secondary winding. Primary winding is not fitted with any power supply, and secondary winding is not connected to any load. It may be resistive, inductive, or capacitive. So in the case 1, a no load condition, S1 and S2 are in open condition. Then after some time, maybe at t is equal to t1, at a t is equal to t1, that implies close switch S1. So now this is closed. Okay. Now what things will change? Now this will draw a current of I0. So this winding will draw, because once you close the switch S1, this primary winding or the primary circuit will become closed. I mean, it becomes short. Initially it was open condition. Now it is closed condition. So since it is a closed path, in the closed path the current will start flowing. So this winding will draw a current of I0 amperes. So this I0 is called as no load current. Okay, no load current. So this I naught will flow through the primary winding. So let us mark this as primary winding P1, primary winding, or you can say it is what we call it as, let us take it is LV, or this is HV, that is low voltage winding, high voltage winding, or you can simply say it is a primary winding or it is a secondary winding. So there are many nomenclatures with which you can call them, it just depends on your assumption. So this I naught will flow through this primary winding and will generate a flux called phi. Example. So this I naught will produce a flux, magnetic flux. Okay, what is a flux means? Magnetic lines of forces. So I am just going liberally, thinking that you know some concepts on this of the transformer, right? Now this flux will travel. This flux is produced in the primary winding, will link its own winding, primary winding. Now there are two laws are going to work in this concept. The production of the flux is one law. Okay, what is that law? It is Oersted law. I will tell you a difference also. Just remember this. What Oersted said, the current is going to produce. Current produces flux. Current produces flux. So this I naught is going to produce flux in the primary winding. Okay, that is because of this law. That is Oersted law. Then the second law is going to work. That is Faraday's law. The second law is Faraday's law. What Faraday's law is saying? The quite opposite of this one. Why I am saying it is quite opposite means, here I told you that Oersted said that the current, if it is flowing through the conductor, produces a flux. But generally current is not a independent variable, it is a dependent variable. What is independent variable? Voltage is the independent variable. That means when I am saying that there is some current flowing through the conductor, it means there is some voltage behind it. So it is simply nothing but the voltage produces current and the current produces flux. That is what the symbolic, the flow of concept. The second one is Faraday's law, which is exactly opposite one. That means the flux produces voltage. The flux produces voltage. So I am saying it as EMF. That's what the Faraday's law. So as per Faraday's law, the EMF is produced, that is equal to minus d phi by dt, and this into number of turns, that is n d phi by dt. Okay. Now according to this rule, so there is one EMF produced here, so that I am taking it as E1. Okay. So as per Faraday's law, some EMF is going to be produced in the primary winding, which is named as E1, and the direction of this E1 is exactly opposite to the direction of V1. It is because of this sign. So this is due to one more law, that is Lenz's law. This is due to Lenz's law. So that means there are three laws are working in tandem. One is Oersted law, because of which this current is going to produce flux. Second one is Faraday's law, because of this flux, and when it is linking with the same winding where it is actually produced, it is going to generate some EMF. That is because of the Faraday's law. That is a quantity is given by Faraday's law. Whereas the direction of this EMF E1 is given by Lenz's law. So that means what Lenz's law is saying, the produced quantity will oppose the very cause of it. That means, for example, how should I say it? It is Lenz's law. Lenz's law means, suppose A is produced by B. Sorry, B is produced because of A. Just take an example. B is produced because of A. Now, as per Lenz's law, this B has to oppose the A. That means a child opposing a parent, because child is the origin of the child is the parent, because a child is what we call given birth by the parents. So the child is opposing the parent, is a very cause of them, right? So B has to oppose A. That is what the Lenz's law. Here, this E1 is coming because of linking of this flux. This flux is coming because of this current. This current is coming because of V1. Because it is the ultimate main source. That means the produced quantity should oppose the cause. Who is the cause here? V1. Because remaining all are dependent variables, not independent variables. Here flux is not independent. Current is not independent. The one and only independent quantity here, water existing on the primary side, is only V1. So the produced quantity should oppose the very cause of it. Okay, what is the very cause? It is not phi, it is not I, it is not remaining anything else. It is only V1. So this E1 sign or polarity is given based on the Lenz's law, according to which the direction of the E1 is exactly opposite to V1. Got it? That means the current flowing through this path right now, I can name it as what? It is V1 minus E1 divided by the impedance of the primary winding. Let me take it as Z1. Okay? Right. Now, so this is happening here. Now this flux not only links the primary winding, but also will travel like this. Okay. Now let me mark this. Right. Since we are in case 1 condition, what is case 1 here? Actually, no load condition, wherein S1 is only in closed condition, whereas S2 is still open. I did not close the switch S2. So that means this secondary winding or high voltage winding is still in open condition. That means it doesn't carry any current. If this is closed, then only it starts taking the current from the transformer to the load. So when this S2 is open, this load is not going to draw any current from the transformer. Okay. So therefore, since the current, let me take it as I2 is zero, this the secondary winding is not going to produce any flux, is not going to produce any EMF, and it is not going to feed anything to the load, maybe current or whatever, power or whatever it may be. Okay. Now we will jump on to case 2. So what is case 2? So let me take it as case 2. So case 2 means what? Actually load condition. So when the transformer is loaded, when transformer is loaded, that means S2 is closed. So when S2 is closed, when S2 is closed, now there is some current flowing through the transformer to the load, that is I2. So the load connected to the secondary winding is going to draw the current from the transformer to feed the load, right? So now what happens? The terminal voltage, whatever it is appearing across the load, can be taken as V2. Okay. Now this I2 will circulate in the secondary winding, which will produce an EMF E2. Okay. And the current I2 is nothing but E2 minus V2 divided by Z2. Okay. So here what is happening? Now I2 started flowing here. Now this I2 will produce some flux here. Let me take it as phi 2. Okay. This current is going to produce phi 2. In fact, I didn't mention here actually. First I2, then coming to phi 2. That means I2, when I2 starts flowing, it will produce phi 2. This phi 2, I2 produces phi 2 again because of this law only, or state. The same tandem, three laws in working in tandem, what I just now told, the same principle will apply here also on secondary winding. So when I2 starts flowing through the secondary winding, it initially produces phi 2. This phi 2 is going to link the same secondary winding, that is called self inductance, self linkages. Because of the self linkages, it is going to produce E2. Again here also, second law is Faraday's law. Then again Lenz's law also works here. So now this phi 2 has to oppose, because it is Lenz's law. This phi 2 has to oppose the cause of it. What is the cause? What is the cause here? Now I'll again go back here. The cause here is phi 2 has to oppose a very cause. That means this, whatever the source that is coming from here, from the what we call primary side. Initially it is V1, then I0, phi, E1, then again this phi is going here, then I2, then phi 2, E2, and finally it is V2. I2 is equal to E2 minus V2 by Z2. Now what will happen? According to Lenz's law, it has to oppose the very cause. What is the very cause here? This flux. The very cause is what here? This flux. Okay. Now coming to here, so it is going to did we miss somewhere any other thing else? Okay, right. So as I just now told you, this phi 2 has to oppose a flux here. Okay, that means the direction of the phi 2, the phi direction is clockwise from here point of view. Now as I told you, it is going to work based on the direction of the flux is based on the Lenz's law. What does Lenz's law says? It has to oppose a very cause. As I just now mentioned, the very cause area is actually this flux. So this flux direction is clockwise. Now according to Lenz's law, this phi 2 direction must be reverse. So I am drawing with the red one. So this is a phi 2, right? Okay. So now the net flux flowing from here to here, what we call, actually I am taking not this as phi 1, instead of phi I am taking phi 1, this is also phi 1. So the difference of this is phi 1 minus phi 2. Let us take it as phi. I'll tell you why later stage. Okay. Now initially this E1 was produced because of phi 1. Let us take flux is measured in Weber, so let us take it is 5 Webers. Okay. Now opposite flux is also coming. Let us take it is phi 2. So maybe let us take it as 2 Webers. And the net flux is phi 1 minus phi 2. You may ask a question, why it is phi 1 minus phi 2? Why not phi 2 minus phi 1? Why it is not phi 2 minus phi 1? Why? Because this entire thing is working because of the power supply connected to primary winding. So therefore, whatever the quantities that are there on the primary winding are definitely more than the quantities which are produced at later stage. So if you compare all the things, V1 is definitely more. Then E1 is less than V1, 100%. V1 is more than E1. Okay. Similarly, when the flux is going from primary winding to secondary winding, E2 is coming. So E2 is less than V1, 100%. No, there is no doubt. And after some time, because of the resistance drop or inductance drop or capacitance drop or impedance drop is removed, the rest of the voltage from E2 is going to V2. That means V2 is less than E2. E2 is less than V1. That means if you compare all the quantities, the one only main quantity which is always more than the rest of all is V1 only. So therefore, if you compare phi 1 and phi 2, definitely phi 1 quantity is more than phi 2 because phi 2 is coming because of phi 1 only. Phi 2 is coming because of phi 1 only. So therefore, there is no chance that phi 2 is more than phi 1. So simply, it is only a higher value minus lower value as per formula. So phi is termed as phi 1 minus phi 2. So let us take it is phi 1 is 5 Webers, phi 2 is 2 Webers. The overall value is net flux value is 3 Webers. That means in this core, in this magnetic core, whatever I am drawing it here, this iron core which is acting like a medium, now it is having only 3 Webers flux. Think of it. Actually, when phi 2 was not there, when only phi 1 was there, phi 1 was actually 5 Webers. Because of this phi 1, you are getting EMF E1, right? Now, this phi 1 is going from primary to secondary. Whereas, according to Lenz's law, and as load is connected, since it is also becoming short circuit, it is going to produce its own flux, that is termed as phi 2. But what Lenz's law says, it has to oppose a cause. What is the cause here? See, all these are coming only because phi 1 is going there. Here, load is connected, I agree. When S2 is closed, does it mean that just only because of closing you are getting everything? No. Flux is going there. When phi 1 is going there, it is going to produce some EMF. Then only current, then only voltage. Right? Again, when current is produced, it is going to produce phi 2. So therefore, all these things are happening because of phi 1. Okay. So this phi 2 direction is to be there in such a way that this has to oppose the phi 1. So therefore, phi 1 is clockwise, phi 2 is anti-clockwise. That means here the net flux is phi 1 minus phi 2. Maybe here or here or here, anywhere it is phi 1 minus phi 2 only. Because it's a common one. So right now, earlier it was phi 1 in the primary winding. Now it is phi 1 minus phi 2. That means the amount of flux in the primary winding has been decreased. By what amount? By phi 2 amount. By what amount? By phi 2 amount. Okay. Now, whatever the amount of flux that is being decreased, to that extent, this EMF value also decreases. Listen carefully. Initially, flux was phi 1 in the primary winding. It has produced E1. Phi 1 produced E1. Now the flux in the primary winding has become phi 1 minus phi 2. That means this phi E1 value decreases 100%. There is no doubt, because as per Faraday's law, the amount of the voltage depends upon the number of flux linkages happening in the winding. So initially flux linkages are more. Why? Because flux value is more. The magnetic lines are more. So therefore linkage is also more. Here the flux has been decreased. By what amount? Phi 2 amount. I am telling repeatedly why, by what amount. You will understand later. So this flux has been decreased by what amount? By phi 2 amount. Okay. Now this reduced flux will also decrease E1. Now what I told here, initially it is current was I0. Initially current was I0. Now what happens? I0 is equal to, as I told you, it is V1 minus E1 by Z1. See, here I did not change V1. V1 is constant. V1 is constant because I am not changing here V1 value. Now for this winding, impedance is also constant. If you ignore the temperature effects, because the heating effect of the transformer is very less. Since we have a cooling mechanisms, the overall heat components are very less. So as a whole, I can say impedance is constant, voltage is also constant. The only variable which can decide the magnitude of the input current is only E1. So here, since the flux is decreased, the induced EMF in the primary winding, which is named as self-induced EMF, is going to decrease. Okay. So when E1 decreases, obviously current increases. When E1 decreases, obviously current also increases. Now I am taking it as what? Initially it was I0. Now I am taking it as plus I1 dash. So this whole I am taking it as I1. Initially it was I0. I will write a little bigger one. So here it is I1. Initially it is I0 plus now it is I1 dash. Now it is I1 dash. What is I1 dash here? What is I0 here? I0 was the original one which was earlier existing when the load was not there. Now because of load connectivity, when load is connected, I2 came into picture. By what amount I2 came into picture? To that amount phi 2 increase, phi 2 produced. By what amount phi 2 produced? By that amount this flux decreased. That is phi 1 minus phi 2. Now by what amount this flux is decreased? By that amount E1 decreased. By what amount E1 decreased? By that amount this I1 dash increases. Now again come to primary winding now. Earlier current was I0 which produced phi 1. Now the current is not phi 0. It is now the current is not I0. It is I0 plus I1 dash. That means this I0 produces phi 1. It is already there. I am not changing this value now. So I0 will as usual produce phi 1. Now this I1 dash will produce phi 1 dash extra. This I1 dash we will produce phi 1 dash. Now tell me, what is the magnitude of this phi 1 dash? It is exactly equal and opposite of phi 2. What is the reason? Here, by adding load, you are getting I2. By I2, you are getting phi 2. By phi 2, value of flux decreased here by that amount. Because of decrease of the flux by phi 2, E1 decreased by the same amount. Because of decrease in E1, there is increase in current by the same amount. So whatever the rise in current in the primary winding is nothing but the current proportional to the excess flux to be produced in the primary winding, which is exactly equal and opposite of phi 2, because it's a chain process. It is coming like a chain process. Magnitude wise it is coming like a chain process. So therefore now the revised flux in the primary winding is phi 1 plus phi 1 dash. Phi 1 plus phi 1 dash is going from left to right. And what is the flux already coming from right to left? It is phi 2. As I told you, phi 1 dash and phi 2 are both equal and opposite. That means phi 1 dash is equal to phi 2, but it is simply minus. So these two will get cancel each other, okay, and the amount again flux is there here again phi 1. Even the load connected, again it is still phi 1. Earlier it was phi 1 only, now it is also phi 1. Now you assume I increase still load. When load is added more, the current will still increase. When the current increases still, the flux also increases still. When the flux increases still higher value, to the same extent flux decreases in the primary winding. To the same extent, proportionately, EMF decreases in the primary winding. To the same proportionate way, this current I0, I1 dash also increases proportional to the same value. Now this increase in current will produce excess flux which is proportional to the phi 2. So that means again this phi 1 dash and this phi 2 will get cancel each other. So as a whole, at any point of time, there is only single flux flowing through the core, that is phi 1. It's a single constant value irrespective of the load, whether you connect the load or disconnect the load, because this phi 1 is what actually it was no load flux. So no load flux only still continuing even after load connectivity also, even if you increase the load also, or even if you decrease the load also, or even completely if you remove the load also, it always maintains a common flux in the medium, that is a magnetic iron core. So simply what I wanted to say here, in the beginning of the session what I told, there are some quantities or components that are maintained as constant in the transformer. In that the first one is flux. It is flux in the core. The quantities which are maintained as constant in the core is flux. So flux in the core, these are the constants. Okay. What else is going to be constant? Here, for this, for this winding, there are number of turns. Let us take it as N1. For this, number of turns is equal to N2. Let us take. So now, since the flux is constant and the number of turns also constant, so I can say the MMF is also constant. MMF is also constant in the transformer core. Okay. Similarly, the third one, finally, the frequency. The frequency is also constant. What is the frequency here actually? I am giving AC power supply to transformer primary winding, and because of the magnetic induction process, this power supply or the electrical power is being transferred from primary winding to secondary winding, and it is feeding to load. Here whatever the voltage that is coming across the load, which is named as the terminal voltage, is also AC only. The nature will not change. You give AC, you will get AC only. So it is a AC to AC only, but it's not like a rectifier to convert like DC to AC or AC to DC. I am not finding any kind of rectifier operation or inverter operation here. We are having only change of level of voltages and transferring of the electrical power in the same nature without any change in energy form. It is converting this electrical power to electrical power only. So if it is AC, it is definitely AC only. Now when I say that it is AC power supply, it is having some frequency. In India, we generally follow 50 Hz frequency. Whether it is a single phase or AC, 3 phase, the frequency of the power supply is waveform, AC waveform is 50 Hz. That is number of cycles per second. So similarly, so as I earlier mentioned, there is a change in the magnitude. V1 is more than E1, E1 is more than E2, and E2 is more than V2. But what I am saying, the nature of the waveforms are always AC only, that is same only, that is V1 or E1 or E2 or V2. They are going to differ in terms of magnitude, but the waveform nature is AC. So therefore the number of cycles also AC only. So in the transformer, the frequency is also maintained as constant. What I mean to say is, suppose if it is, if you take a graph here. Suppose if this is V1, maybe since it is exactly opposite one, I can say it is this is E1 or E2, and E1 and E2 are both in phase. So here maybe less. So this is E2, like that. That means the waveform magnitude will change, but the number of cycles that is waveform is going to perform in the unit time, that is seconds, it will not change. So therefore the frequency component is also constant. Okay, and more or less the copper losses are also constant. Copper losses also constant. I mean, I'm not saying that they are strictly constant, but we can say approximately the copper loss constant, and the iron loss is also constant in the transformer. So when it is coming to losses, I don't say that it's strictly say we can say that it is a loss. The losses are constant, but approximately the losses are also constant. So that is the reason here in transformer voltage is inversely proportional to current. That means if you step up the voltage, the current will decrease. If you step down the voltage, the current will increase. What is the reason? Because the overall power is constant. See, when input power, when the losses in the medium are same and constant, the output power is also constant. So when input power is exactly same as output power, and I mentioned already, it is going to give 98% efficiency. That means the loss component is negligible here. So when the loss is negligible, I can simply say that the input power is approximately equal to output power. So when the output power is equal to input power, that means power is constant. So when the power is constant, I can say it is V is approximately proportional to 1 by I. That means if V is increased, I decreases. If V decreased, I increases. That means if the voltage is stepped up, current will be stepped down. If the voltage is stepped down, the current will be stepped up. So these things will happen in the transformer. That means as a whole, I'll be summarizing it. In transformer, flux is constant in the core, MMF is constant, frequency is constant. These are strictly constant. Whereas approximately losses are also constant in the transformer. So this is a basic concept that how the flux can be maintained, and also the other components are maintained as constant in the transformer. Hope you understood well. If you have any queries or doubts, you can post it in comment box. Okay, next we'll continue some other topics in the next session. Thank you all. Please go through all my videos. Please share it to your friends. If you like, please kindly support the channel and subscribe to it, and also press the bell button to have a notification, so as and when I upload the videos. So please kindly share it to your friends, or if you have any known circle students, you can also please refer my videos. I think I'm not dealing with the normal normal level of explanations or teachings, because it is not a generally discussed in a flow of lesson plan. So it is something different I'm trying to explain, which are not exactly known, given much more explanation in the textbooks also. So please kindly go through the videos. If you understood and if you like the videos, please try to share it to your friends also, and please try to give the utmost publicity or wide publicity to the YouTube channel also. So for which I will be very much thankful. That is the greatest help that you can do to sustain or retain this channel for a long time. Thank you all. Thank you. Good night.